study multivariable regression. In this multivariable regression is a part of the linear regression. In the experiment number 5, for that experiment number 5, the implementation of multivariable regressions. For this objective, to understand the concept of multivariable, multiple linear regression. To second objective, to train the model, regression model on data set with the multiple independent features to evaluate the performance, the regression model using error matrix. So that's the problem statement to implement a multivariable regression model to predict the target variable based on multiple independent features using Python scikit-learn. With the example, this can predict the marks for students in the multiple variables like study hours, mobile hours, sleeping hours, and after that, dependent on that variables, we can predict the final output for this is the multi-variable regression model because one more than two variables depend on regression. The theory for this multivariable, it is an extension of simple linear regression that uses two or more independent variables features to predict the dependent variable that is the target. With here, machine learning always remember that independent variable is called features and dependent variable is target, is output. A model can be represented as a evaluation matrix for that. After getting the result, we must have to evaluate that results is accurate or something extra given on that basis. For that evaluation, we can use here the evaluation matrix format formula for that. Then the three concepts, evaluation matrix of linear regression and logistic regressions in mean square error. And second one is the root mean square error, RMSE. The third one is the R2 score. It's also known as godness of fit. With this, here the algorithm, first of all, we give import the necessary libraries like NumPy, Pandas, sklearn, and load the explore dataset. And that dataset must be split into two parts. First is training and testing. It is a likely 80-20 percentage formula. And after that, the apply multivariable regression will be scikit-learn linear regression and train the model for training data and predict the target variable for test data. And after that prediction we receive, we must evaluate that performance using MSC mean square error, root mean square error, or R2 square error. After the evaluation of this, display of the regression coefficient and intercept. So first of all, here we must start here with the code, actual code for this experiment number 5, which is multivariable regression. In this, we can must comment on this experiment number experiment number 5, multivariable multivariable regression multivariable regression. After that, we can must import first must required libraries which is uh, already predefined in this Python library structure. After that, we can must import NumPy as entry from sklearn linear model, sklearn models, sklearn model. After this, we have understood yes, sklearn dot model selection, sklearn after that model selection, mm, sklearn dot model selection. This is the model selection, and after that input trained linear model, train test split function, which is already predefined. So that's you can divide the model into two parts. So it's the train underscore train underscore testing and split. Then that we can easily access the linear model, linear regression, and the scale matrix from mean square figure transfer, which is predefined so that is coming automatically. We can use for this the data. Data is given also data set for that. We can here use the data, which is area and frequency for that data. Data we use the total values, total number of the readings for that values data in the data we can do the um, x1 which is here given is the area which is access give the name of the that column is in variable multiple variable area in that we give the total 1000 2000 and like this we can give the values 3000 4000 and 5000. After this x2 variable and multiple variables we give the bedrooms for prediction of price of house is the bedroom variable you can give it number of bedrooms here 2 bedrooms 3 bedrooms 2 BHK 3 BHK 4 BHK 5 BHK 1 2 3 4 5 so also required 1 2 3 4 5 six bedrooms. Here bedrooms number till the six. So can age can here give the third point is the age. Variable prediction. Age is three prediction 10, 15, 20, 25, 30. So we can here see like this age we also require another price factor which is target variable price for that price given in lakhs. Here is 40 lakhs, 50 lakhs, 60 lakhs, 70 lakhs, and last one is just 80 lakhs. We give here the parameters of for this data set. Here data frame use this variable. After this, you can give the features for this x equal to area bedroom age, yes, and that y equal to the data frame equal to price. So here we can use automatically coming which given which declare about data sets for me. And after that is give the area bedroom age and price is y axis means y is prediction of price on the basis of area bedroom and age. We can multivariable regression is because area bedroom and age is multiple multivariables we can give this input as a machine learning model so that we can predict the price. After that, the data is must be divided into two parts. Must be training and testing data set. After that, we can here give the Y train, Y test, and Y train, X test, X train, X test. After that, create model, create and train model. Model equal to linear regression. Model equal linear regression. Model dot fit X train Y train. Switch after that prediction. Y prediction equal to model dot predict X step. After that, we here see the mean square error. Mean square error, the evaluation matrix format in this prediction and MSE, and we also required RMSE equal to and R2 square. And after that, we see here mean square error, and the printed values, root mean square error, R2 square, R2 squares, and after that, we here this completed this code, and after this running this code, we receive an output here, mean square error equal to 0. Some error in this our code. First of all, we check the check the message 1 to 10. Multiple navigation display results. We can print here coefficient intercept and use mean square error, root mean square errors, and ask for error. This is the evaluation matrix used for the multivariable in navigation. After this is compare the actual and predicted results. For the actual results, we can access the y best values, predicted price prediction. So actual versus prediction is print result visualization for the actual price and predicted price. So after this, we can run this two programs, and here the data set which is provided the value for the multivariable linear regression. Here is the data set we given inserted use data frame for that multivariable linear regression is coefficient. This is the coefficient intercepts mean square of 0, 0, and R2 square is equal to 1. The actual versus predicted value is actual value we are given for that is actual value 70 lakhs, and predicted price also same is predicted. So that's when this actual and predicted house price is same. This is increasing by day. After this, this is the dependent of this is the example of linear regression or multiple variable linear regressions. So thank you for this watching. Thank you very much. Thank you.